Good afternoon, dear students. Welcome to another session on Introduction to Data Structures and Algorithms. Today we are discussing on Module 3. So this is Dr. Rama Satish from RNS Institute of Technology. And in Module 3 we are going to discuss today on linked list and stacks. What is exactly linked list? Linked list is a collection of data elements which you call it as nodes. They are logically connected to each other. Whenever there is a need to add a new element to the list, new node is created and it is added wherever you want. You want at the beginning, you want at the end, you want in between, yes, you can add it. So overall it looks like a train. And the question arises, why linked list? Why? What is the main use of linked list? Remember, dear students, array allocates a fixed amount of memory before the program starts execution. And of course, there is no chance that you can alter the fixed allocated memory of an array. You cannot alter. And of course, whether you use it or not, that is whatever you have declared in the program, so much memory is allocated. So of course, many times it gives you underutilization of that memory. And of course, if there are any chance that you want to increase more data into an array, the actual capacity, beyond actual capacity, there is no way of doing it. So that is the major reason we make use of linked list. And of course, linked list has data part and the next pointer usually holds to the next node, and the beginning node is containing a special pointer called first pointer. It is also called header node, and it contains a special pointer called first. The last node of the linked list normally pointing to null value, and this indicates this is the last node. If the pointer in the next pointer in the node, if it is pointing to null, then that is the indication that that is a last node. And of course, so in order to identify last node, there is a special pointer called last is pointed there. So look at there, this figure 5.1 depicts the logical representation of the linked list, where the first and last are special pointers that are pointing to first node and last node. Last node is pointing to null, and every node has information, and next pointer is pointing to the next node. So like this it will be pointing. Next, advantages of linked list are: first, it facilitates dynamic memory management by allowing elements to be added or deleted at any time during the program execution. And the second one is linked list ensures the efficient utilization of memory space. Efficiently it utilizes the memory space. And third one is it is very easy to insert an element and delete an element, whereas unlike in arrays, you have to shift some elements, you have to move elements for doing insertion or deletion operation. So that is not there. Straight away you can delete, straight away you can insert by altering the pointers. But what are the disadvantages? So one disadvantage is, along with the data or information, you have to store an extra pointer space, that is to hold the next address, next node's address. Pointer, that is one thing, but that will certainly increases some memory. That will take some memory compared to arrays. Array, you don't have that problem, all are continuously allocated. Here they are not continuously allocated, but there is a pointer, extra pointer. This extra pointer is the some overhead burden. Second thing is, directly in arrays you can access EF5, you can access, but if you want to access the fifth element or sixth element in linked list, you have to start from the first node, beginning node, and it has to go the next node, next node, next node, next node, and you have to reach the fifth node. But direct accessing is not there in the linked list. That is the second disadvantage. Many times in the examination they ask, compare arrays against linked list and identify their strengths and weaknesses. So this table talks about the strengths of the array. The first strength of the array is random access. They require less memory compared to linked list, and better catch locality, so it can easily catch the elements. The problem with arrays are slow insertion and deletion time. Size is fixed. Properly it will never utilize the memory, inefficient utilization of the memory allocation. Whereas if you compare a linked list, it is very fast in insertion and deletion, and it is a dynamic size. Size can grow based on requirement, and it will efficiently manage the allocation of memory. But one major drawback is it is slow in accessing or searching the elements. So slow search time. More memory is required as each node has an additional storage requirement to store pointer. So that is the comparative study between arrays and linked list. So types of linked list. If you look at the first one, single linked list, singly linked list, where one data, one next pointer, and whatever so far we have discussed, it is singly linked list. And the second one is doubly linked list. In doubly linked list, what happens? There is a another pointer which points to the previous node and one to the next node. We'll discuss this doubly linked list in the upcoming classes. Third one is circular linked list. In circular linked list, what happens? Circular, as the name says, the last node, it will never point to the null. It will point to the starting node. So what happens? It creates a circular. That's why it is called circular linked list. So that's all for today's class. In the next class, we'll be talking about linked list implementation. Thank you. All the class recordings are available in this particular website. Have a wonderful day.